Okay, hello Shen. Hi, how are you? Thank you so much for accepting our invite to be a guest in our podcast. Again, welcome in our podcast.
Thank you. Thank you for having me. I'm looking forward to it.
Nice pleasure. And just to take this opportunity, kindly help us to introduce yourself to our audience.
Shane Gibson, born and bred in sunny New Zealand, travel the world a little bit, but still located here most of the time. I kind of break my career down into 3 decades. The first decade was working for large software vendors based here in New Zealand, but for some of the global software vendors, started off in financials and then very quickly decided I didn't like that. So I moved into data and analytics, which I've loved for 30 odd years. I kind of position my second decade as founding and running a consulting company. So still in data and analytics. Your typical, 20-person consulting company. So we used to do the gambit of strategy, implementation, deployment, all the consulting work, all the way through to support, typically for large banks, government agencies, insurance companies, those kind of things.
Yeah.
And my last decade's been split between agile coaching of data and analytics teams, so teaching them new ways of working to kind of change the way they work and make it more successful and more fun. And a startup called Agile Data, so
Uh,
into the product space for data. So that's kind of 30 years and 30 seconds.
yeah.
Excellent. Okay, so given you're an Oracle guy, got to ask the question. Oracle Warehouse Builder or Oracle Data Integrator? When did you start
Ah,
in the Oracle world?
you are the second only few people who knows Warehouse Builder. I was the one who started working on Oracle Warehouse Builder in 2005 in Singapore. And along with that, Discoverer. If you know Warehouse
Oh,
Builder, you know
yeah.
Discoverer,
Yeah,
right?
yeah, yeah. Back in the
Yeah,
old days, yeah.
yeah, yeah, yeah,
After Oracle reports, but
yeah, yeah, yeah.
and after Oracle Express, because I
Yes,
was there during those days when back when we had OLAP cubes, which funny enough we're getting again, right? The old
it's
OLAP
coming
cubes
back.
seem to be back again, but with a different name. Yeah.
Yeah, lot of not a lot of people use cubes because it's very heavy because data ownership was not there last time. Now
Mm.
people are trying to understand what data ownership because when you create a cube, it's very huge, it's high maintenance. If you don't have an owner, you end up creating, but you can't delete it because nobody knows it's used for which purpose. You have to track it for audit purpose, compliance XYZ. So that takes a lot of time last time, and storage was not cheap last time. Now object storage is very cheap. So people are
Yeah.
coming towards, yeah, this piece, and let's see how it goes. But not a lot of people, first of all, knows Warehouse Builder. Thank you so much for recalling my old memories. And not a lot of people knows what is cube. Hardly anybody knows what is cube nowadays.
Look, nobody knows what data modeling is, right? Or why we do it, or what a BI semantic layer is.
Yeah, yeah,
There's a whole lot of things that have been lost, but we've gained lots, right? So, to your point, many years ago, we had to buy cube technology, um, and we had to deploy it separately from the data warehouse database
yeah.
because we were constrained on hardware and storage. And so it was a way of decoupling that piece of the compute from our main appliance.
Hmm.
That's changed now, right? With object storage, with cloud analytics databases like BigQuery and Snowflake, we get performance where we can be a little bit more lazy. We can do that heavy OLAP type computation, that aggregation in those databases without having to buy yet another piece of technology. It has moved on in a good way. Yeah.
Yeah,
But we've lost some of
actually,
the arts. Yeah.
yeah. Yeah, so data modeling is still key, but there are many things coming in data modeling, right? Uh, Example is the first in OLAP world, actually confuse warehousing with the OLAP. OLAP is more towards cubing things, not data preparation zone. Data preparation zone is little bit different, which is Bill and Mon kind of 3NF, and then data vault comes in and Kimball star schema was there. I'm a big fan of having Kimball into the semantic layer, not in data preparation layer. But different people have different prospects, right? So yeah, and things are moving in a very good direction. An example is we always wanted storage and compute layer separate, right? Now, because of this object storage, yes, storage layer has been segregated with compute. By right, it should be. That is one of the key principle of my DAS architecture. But still, this vendor lock-in is still there. We can talk about big vendors like Snowflake and Databricks doing very good. But again, the moment you start using their managed tables, your storage is per K, no doubt. But the moment you come from Snow tables or Delta tables, your file system is locked with them. External party cannot hit or make sense of the Perky files because the way they write Perky files, their own metadata or catalog can understand that. But just recently, yesterday or day before yesterday, yesterday morning, I had this. I have yet to upload that podcast. I had a podcast with one of the guy in US. It was a very good session. Maybe you can have a look later once I upload it. We discussed iceberg, hoodie, and then delta tables, and then snow. We did a comparison, and Apache X table as well. The beauty of this X table and the other thing, now we have, last time we were discussing about storage versus compute. Now there's a table layer there as well, which is cataloging. Now you have Perke, now you have table format, and then you have compute. So end of the day, this Perke files, data files can remain as it forever, which is the ideal way that you write once, don't change it. And compute layer and table format can change. So we are going in the right direction, and yeah, learning, it's moving very fast, especially about our today's topic, right? So you have, thanks for sharing so many topics. I will touch base on two, right?
Yeah, I was going to say, I'd love to see which of the shopping list we're going to talk about.
So I have shortlisted that to discuss about why data product, data contracts, and AI agents will be hot in 2025. Second one, I will touch base. Would like to touch base on good, bad, and ugly use cases for LLM in data products, data platform. This is very key nowadays. And since I have seen that green picture behind you, information product canvas, let's also touch base as well. That
Ooh,
how to
gonna
gather
be
data
busy.
requirements. Yeah.
Yeah, it's going to be a busy podcast. All right, let's do it.
It'll be good, right? Because these three topics, right? You are absolutely right. Nowadays, the biggest challenge, okay, how to put it challenge? I'm just setting the context, right? Nowadays, everybody want to create a data product. People are
Mhm.
coming out of centralized environment, which was an enterprise warehouse. We learned if you are dependent on centralized warehouse or whatever model you can call it, and if you have a centralized team, there's a dependency and delays comes. They, not everybody can learn all domains, so people started moving toward domain kind of preparation. That is where data product comes in, data mesh comes in. Actually, data mesh concept came in, but hardly anybody is using data mesh because it has so many requirements. But what good impact data mesh left it, they told people you should create data products based on domains. That was a good concept came in, right? But at the same time, LLM came in. Now, when LLM came in, everybody want to jump in, and that is where you are talking about use cases for LLM. 90% LLM requirements coming for me is all crap. It's not doable. It's not the right way to do it. And then data products. So which one you want to start?
Start off with data products, right?
Okay.
And again, I'm old and grumpy, right? So been around for a while. So the idea of domain orientated data is not new, right? We've had it in software engineering for ages,
Hmm.
but we also have had it in data for a long time. So in the old days, we used to do subject areas. So if we
Oh
were
yeah.
running a Kimball model, right, a dimensional model, a star schema with facts and dimensions, our fact tables used to be bound to subject areas. And even though we had centralized teams, we often would have more than one group of people working on more than one thing. And we would often create the boundary between those teams around those subject areas. So, if we're and I'll typically use e-commerce examples, right? Because it's kind of the one that lots of people understand. We may have a team working around the ordering process, right? How customers are ordering those products. We'd have another team working around the inventory management and stock and shipping. And we'd probably have a third team working around finance and HR and some of those shared service type things. They're effectively domains. And we call them subject areas. So it
Hmm.
always, there's lots of new lamps for old. but it's a valuable process, right? It's a breaking your data and your teams up based on domains is one way to scale your organization if you want more than one team. So it's really valuable. So yeah, data products kind of given us another lease of life around this domain orientated data. And that's valuable. But yeah, it's been around for a while, right? We just kind
Yeah.
of forgot it. Big data kind of forgot it because we thought stick everything in Hadoop, don't worry about any classification. It'll take care of itself. We don't need any kind of boundary because it'll just eat the elephant. And that actually didn't end up being true. Yeah.
Yeah, so you're absolutely right. These concepts are there. As you correctly mentioned, we used to call it subject area. Same is like this old our practice like landing, staging, and transformation layer. Now
Oh,
they call it
you mean the
medallion.
medallion
They
architecture?
call it
Yeah.
medallion. And
So we and again it's language, right? We call ours history, designed, and consume.
yeah,
We used to call it persistent staging, something else, and presentation, right? Everybody's got a different name. But what's interesting is while the marketing team from Databricks have done a brilliant job at reinvigorating the idea of a three-layered or three-tiered data architecture, we got no more detail, right? So if you say to somebody, what's in silver? There's no more patterns. Like we still haven't solved the problem of reusable immutable patterns that say do this in bronze, do this in silver, do this in gold. And I'm a great sci-fi fan, so I keep talking about everybody's inventing vibranium, right? Which is that mystical, magical metal layer that comes after gold. So again, we kind of focus on re-buzzwashing what we knew, and often we don't focus on how do we go to the next step? How do we solve the problem that hasn't been solved yet in a repeatable way? How do we iterate on our ways of working? But again, it's glad to see that people are now talking about three-tier architectures again because they have value in certain context.
yeah, correct. And when we talk about medallion, right, that is where my DAS architecture comes on. And right, the biggest challenge I see nowadays is AI do not have data.
Mhm.
Right now, data is sitting in silos. We came for our OLAP, so we can get rid of OLTP silo data sitting here. We used to bring in OLAP, which is warehousing. Now, what happens? We have so many OLAPs. We have so many small model settings. So, for me, OLAP systems become siloed nowadays. And then comes AI. When AI want a data, we all know data science 19% they use Excel as a source, right? So for them, 80% of their work is to massage data, create feature stores. That is not their work. Their work is data engineering. So when I came up with this DAS, yes, it's a three-tier architecture there, but I bring in AI data sources and practices inside that. So my Alpha Bravo Charlie have structured, semi-structured, and unstructured as well in all three tiers. And I call it this our their silver. I call it data preparation layer where you have to prepare data. Either you can prepare in 3NF or you can prepare in data vault. You can prepare in focal point. You can prepare anchor, all those data model where you can prepare it. And then you go into semantic. So Charlie is semantic. In semantic, you can have NoSQLs, you can have dimension models, you can have cubes, all those things you can have in there. So yeah, this is a very interesting, architecture coming back. Now coming back to this data product, right? So we are also talking about data product, which is domain specific. So it's a good catch if people start okay, before I go into contract, right? Let's touch base data ownerships because that is very important. The moment you start creating data product, we are saying ideally there should be a domain owner who should own all these products. Example is sales. If marketing need a data from sales, a data product should be created within sales domain and someone owner need to be there. What do you say about that?
Um, so let me just use a technique first before I answer that question, but I will answer it. What I often do is I find everybody has a different definition for the same term, right? When we're in an organization and we say active customer, as data people, we kind of laugh about the fact that stakeholders can't give us a single definition of customer, let alone active customer.
Hmm.
Yet in the data world, we are worse than stakeholders in an organization because we argue the semantics of semantics all the time.
Hmm.
And so one of the techniques I use when I'm having a conversation with somebody is I ask them to anchor. I say, you anchor your definition of that term, and I'll anchor my definition of that term. And we're not going to agree, but we're not going to argue the semantic differences of our definitions. What we're going to say is, okay, now I understand how you see it, and you understand how I see it. We can move on with the conversation. So you give me your definition of a data product, and then I'll give you mine. And then we'll use that as an anchoring for the rest of the conversation around data products.
Okay, so that is how you look into it. So what about the data product ownership? Do you
No, no,
see
but what's your definition of a data product? If you're going to explain to somebody what a data product is, how would you explain your definition?
for me, data product is something which is solving a problem,
Okay.
a specific problem. That is the one data product itself. That's how I look at it. And I go and find out who is the product owner. And that product owner, of course, that product is part of the domain. So we need to have a domain owner first, which can be a department or LLB. And within that domain, you need to find a product owner who wants a business use case problem statement, who has a problem statement. You have to solve that problem. That is, for me, that is what data product. What do you think about that?
Okay, that's good. I like that one. I'll just read out. So I've been using the term information product for years, and I kind of can't give it up. Because it's how I think, right? So what I talk about is an information product, right? It's a product, and I'll come back to why that's important. It encapsulates data, code, analytics, and visualization, right? So it's everything you need for that product to be valuable. It delivers information which is in a defined boundary, right? So you
Yeah.
can't have one product to rule them all. And enables action and outcomes. So somebody's going to use that information to do something in the organization, and if
Yes.
they do that, there'll be an outcome for that organization, and that outcome should drive business value, right? And
Correct.
so often we pick up some of the stuff in product thinking, and we talk about value, viability, and feasibility,
Hmm.
right? Which is one of those ones you talked about, right? What's the problem we're trying to solve? And if there's no problem, then it's a data asset, right?
Yeah.
Because it's just a bunch of data that doesn't. So within that boundary, we go back to product ownership or data product ownership. And my test for this whether the organization is thinking it in true product thinking or they're thinking it in data governance thinking. And the way I test it is, let's just say I'm the product owner for the sales domain, right? So I own, in theory, because I'm the product owner, I
Hmm.
own sales data. Am I allowed to sell access to that data, aggregated anonymized data, to another organization without asking anybody else?
If you are an
Because if I
owner,
am,
yeah,
I'm the owner, right? I'm the
yeah,
product manager. I'm the owner. I'm there to get value from that data. I get value internally. I may get value externally. Or do I actually have to go and ask a whole lot of other stakeholders and a whole lot of hierarchies and a whole lot of committees and a whole lot of business cases? Because if I'm not that, then actually I'm the the data guardian, right? I may
yeah,
be a steward, whatever. I'm there to curate it. I'm there to look after it. I'm there to make sure it's healthy, but I don't own it because I can't sell it. And so
yeah,
I think we should be really careful of the word owner because it comes with a whole lot of semantic meaning. I own my car. I don't own the house that we rent. I can sell
yeah,
my car. I cannot sell the house that we rent, but I have to look after it, right? I have to be a steward of the house. I have to be a guardian. I can't trash it, but I don't own it. And so I think, again, when we bring these new terms into data, we've
hmm,
got to make sure we lose the old legacy thinking, around data governance and data stewards and lots of committees having lots of chats about this data because that's not actually doing us a service. Yeah.
yes. Actually, it's a very good point, right? Reason being, when we talk about data product ownership comes. When data product comes, domain comes. When domain comes, there has to be a domain owner as well. So as you correctly mentioned, if there is a data owner, that data owner should be, again, the next discussion comes on this data product is solving a business problem, or this data, when we
Mhm.
say business problem, direct business problem where you can have dashboards and analytics, or this data product is going to become a data as a product, so another product can consume from it, right? So the moment it becomes data as a product, your data model is built to serve someone else so they can create their own data product, and then you cannot change that without telling all downstreams. But If it is only a data product which is serving analytics or dashboard for a specific business problem, then yes, you can change it. It can be agile because business requirement keep changing. We all know after 12 or 13 months, everything changes. All processes changes, right? Then you can change this. But if it is a data as a product to serve to another data product, then it's very difficult to change it because you have to make sure all downstreams are up to date for that. So yeah, this ownership, I want to spend a little bit more time onto it because this is a big confusion nowadays. Everybody want to jump into LLM. The moment you jump into LLM, unstructured data comes. The moment unstructured data comes, data ownership become a problem because in unstructured world you cannot have a segregation of access matrix just like you have in relational databases. You can't have it. So now the question is who's the owner, right? Is a domain owner? Is a product owner?
Yeah. So what's going to be interesting though, right, is we can't have it yet, right? So this is one interesting thing about unstructured. So again, let me give you my semantic
Hmm.
definitions, right? When I talk about structured, I'm talking about databases, right? Rows and columns where there's a
Yeah.
schema like typically enforced, right? There is a structure that's defined
Yeah.
and it's adhered to. When I talk about semi-structured, I'm talking about CSV files and those kind of things where there is an idea of a schema of a structure, but it's not enforced, and people are going to add new data in there with a new comma, and it's going to break everything we rely on.
Hmm.
And when I talk about unstructured, I'm talking about video, voice, those kind of objects, right, where they're
Yep.
more binary objects. And to date, we've been gifted with the fact that structured data had a whole lot of technology around it to help manage it below the blob, right? So as you said, right, we got rows and columns. We can apply security on a row, security on a column, right? We
Yeah.
can subset that structured data and do a whole lot of really great stuff to it. And in the past, when we talked about voice and video, they were binary objects, right? They kind of, yeah, we put some metadata around them, but that was it. But what we're seeing now with the LLMs and with the multimodal stuff is the machine is starting to be able to decompose those binary objects into subsets. So, for example, there's some great demos from Google where you can point their stuff at a movie and you can say to the multimodal LLM, was it LLM? Because it's more a video model. So I've never quite worked out is that an LLM or not. But anyway, at the model, and you can say, tell me in the movie where there was a red lamp that was turned on. And it will actually say, you know, 35 minutes in at this stage, there's a red lamp in the corner of the room. And so the models are starting to decompose structured data down to subcomponents like we've done with unstructured, with structured. And so that's going to be really interesting, right? Because now we have slightly more control. So in your example, potentially in the future, we'll be able to do PII, privacy security stuff against a video by saying wherever you see Shane, remove him from the video. I
Yeah.
mean, kind of
Actually,
intriguing, right?
yeah. Actually, yes. There are cognitive services. End of the day, for unstructured piece, for me, is to analyze text. Why I say text? Because audio, video, all converted into a text. Even this machine learning cognitive services, when you give them an image, what they do, look at the image, they define the metadata of the image somewhere back there. When they define it, it become a text. The moment it become a text, they throw into LLM backend and they create the context on top of it, and then they answer you. It's a red, it's a green, because all those numbers converted into ASCII to digital, right? So yeah, so for me, if a text is coming, either that text is converted from audio and video and XYZ, it's a text, and text has to have a domain. And the moment you text have a domain, you need to have taxonomies and ontologies for each domain to understand what it is actually. Until and unless
Yeah.
you don't understand, how you can take a decision.
And let's go back to that idea of ownership now, right? So let's agree that in the last 30 years, we've been particularly bad at ownership of data. Because as you said, right, we go, well, we've got a subject matter around sales, we've got a core business process, which is customer orders product, customer pays for product. Both of those processes are potentially owned by a different lead, right? A different team in the organization. We now have a domain, right? We may have finance versus sales versus marketing. And even with those small matrix of teams and capability to divide domains, we have been particularly bad at it. And now we throw in unstructured data, right?
Yeah.
And say, oh, now we're going to go manage ownership and domains across that. Well, we can't do it with the relatively simple stuff. I'm not sure how we're going to do it when it gets a bit harder and a bit bigger. So we'll see.
Yeah, so just to bring this data contracts into our discussion, right? So I have been one guy, Francisco Papini, is the founder of innovator of Papini Bridge. I had a session with them. He introduced graph theory to me. I started researching into it, and it's mind blowing. It's because we all know taxonomies and ontologies. Then there's a guy, Daniel. Uh, he has come up with meta graph concept. So when you go into this world, so I am coming towards the ownership as well, right? Right now, the ownership, normally what you do, hey, business, what do you want? Business give you use cases. Based on use cases, you create user stories, and all is theoretical. But now this graphs comes, knowledge graphs comes. So nowadays a new trend is coming. When you are talking to business to define their user story or use case, you create a graph. You have taxonomy, you have ontology, you create meta graph to join all those things. And meta graph, you have a knowledge graph, right? Once you have it, that is based on your use case or based on your domain. So very easy to show you, hey, Shane, this is what you want, right? So once you say, yeah, this is what you want, there's no going back from there, right? You are the owner because you agreed on this whole graph. And when you have this whole meta graph there, based on meta graph, we create a data model. And when we create a data model, we find relevant information from unstructured and convert into structure as well, whatever you want to do into a data model. So that is where I think data contracts come into picture, because when you are defining consumers and producers, you have to tell them what are the rules, what are the regulatory, what are the purging policies, and XYZ. So let's discuss, just put some light onto data
Okay.
contracts and then move on.
Yep. So before we get there, let's just go back to that idea of product owner.
Mm,
And what I'm seeing is a start of a change in the market where we start talking about product managers, right? Data
mm,
product managers. And so instead of asking the stakeholders what they want, what data do you need? They're
mm,
changing the stance to say what business problem are you trying to solve. So just like a product manager for a software company would go out and do customer discovery, right? They go look at the problem space. We're starting to see data people do that, right? Where they
yeah,
don't wait for a Jira ticket or a request for data. They actually start working in the business with the stakeholders around that problem domain and then saying, well, this is how data could help it. And I think with the advent of AI agents and LLMs, that's going to accelerate that behavior because
yeah.
if the data teams don't get off their butts and actually start solving business problems with the stakeholders rather than waiting for a request, people with the LLM tools are going to do it without us, right? And so that's interesting. So for me, I encourage people now to take product management thinking, right? The idea of problems, ideation, discovery, when I talk about the left-hand side of the continuum, before we get into design and build. And what data people tend to do, like good technologists, we always focus on the technology, right? And the data. We always focus on our work, our kitchen, because we want to get better at it. And that's great, right? But when we're talking to people, we should be really clear that we're talking about things that are important to us and other data people versus
Mm,
things that are important to stakeholders. So if we take that and let's talk about data contracts, right? If you go and ask a stakeholder what one of their major frustrations is with a data team is time to market. It
mm.
takes too long. You go and talk to a stakeholder and they ask you how long it's going to take to do something, and you sit there and you go, yeah, we haven't got that data, right? We haven't collected it. It's sitting in SAP or Salesforce or somewhere else, right? And every data person knows at that stage we suck our teeth like a builder. When you get a quote for a builder to come into your house or a plumber, right? And they come in and you say, how much is it? And they go, that's a big job. As soon as we hear the word new data source, we go, oh, yeah, it's going to take a while because we know it takes a while, right? And why does it take
Mm.
a while? Because we're hitting this unknown, right? We've got this technology we've never touched before. We've got to go talk to. We've got these structures we don't understand. We don't understand what the software engineering teams are doing to that product very often, how often it's going to kill us, right? We know that it's a dangerous place to go. Um, and so the idea of data contracts and my thinking around data contracts comes from the work that Andrew Jones has done, right? So lots of there's a few different people with different views, but I kind of talking about it the way that he talks about it, right? And so one of the first things is, can we ever get to that nirvana where instead of us going and grabbing the data from the source system, it gives it to us? And
Hmm.
can we go from a difference between where we define what we want to that system defining what it will give us? And can we move from it giving us the data and us saying it doesn't meet the contract to it checking the contract before it gives it to us? And if we can do all those things, then our life in the data world will become so much happier and our time to market will become so much faster. Now, the problem with that pattern is it requires a whole lot of things to be in place.
Hmm.
So, in the way Andrew talks about it, typically the software development is done in the organization, right? Because if you're using Salesforce or you're using SAP, you can't force those vendors to give you a contract for the data that's enforceable.
Yeah.
And it requires the organization to be happy that it's going to move the workload for that contract from the data team to the software engineering team, right? Because now they're creating the contract and they're enforcing it on their side, not us. And it relies on the fact that when that software engineering team's really busy, and there's a trade-off decision between adding a new widget to the e-commerce website, which is going to generate $1 million in revenue, or enforcing the contract for that new field so the data team are happy, that
Hmm.
that prioritization is going to happen, right? And that the stakeholder, the manager of that software product, is not going to make a trade-off decision and not worry about the contract. And in my experience, that is very rare that we see organizations that are willing to make all those trade-off decisions. Oh, and the last one is the software engineering team have to actually become a data team to a degree, right? They have to get the skills from data to be able to create those contracts, enforce them, and understand the structures of the data. So that's kind of the first thing around contracts, right? But the core of it, which is we just don't go in with a CDC tool and hit your database and pull it all back and wear the cost on our side.
Hmm.
We just hit your API and that data contract, or you send it to us, that data contract's enforced by you. It's an agreement, it isn't a contract, and neither of us breach it. It's a great pattern, just really, really hard to implement. Does that make sense?
Yeah, perfect, right. So see, that is where if we go toward data contracts, correct me if I'm wrong, if we end up creating this knowledge graphs or graph theory, and based on the graph theory, we already agreed based on the use case, this is what we want, and then we create this data contract, and then nobody can break this data contract because this data contract is tagged with the requirement which can visually available and agreed by everyone. Does this make sense?
Yeah, yeah. And so the way Andrew talks about it is around about policies, right? Because
Yep.
I had him on the podcast and he took me on this really interesting journey of not what I expected, right? So he goes, okay, so if we have this idea that a contract is a policy, right? The policy is enforced and the policy is an agreement between one or many parties, then we
Hmm.
can use that pattern in many different ways. We can trade a contract for security.
Yeah.
We can create a contract for deployment. We can create a contract for data freshness or the SLA. We can create a contract for our dashboards. Because
Yeah.
all we're saying is that there's a programmatic way of checking that what we agreed has actually happened. So it becomes a language, right? A system enforceable language, which when you look at data mesh, good book of principles, absolutely no implementation, which frustrated me. But the idea of federated data governance, right? This idea of policies being set and then everybody being held to account to those policies programmatically. That's a great pattern. Again, really see it implemented because it's a hard thing to implement.
Yeah, see, that is where I mentioned that whatever data mesh is, nothing wrong with it. Concept is awesome, but how to implement it, for that the whole organization data culture need to change. Everybody have to bind with that. There has to be a proper governance teams. Everybody need to know what they do. Then there's the governance teams at a domain level. There's the governance team at a centralized level. So all those things making it possible is little bit. We are going there. We are not
Yeah.
yet there. We are on it because the moment nowadays everybody start realizing the importance of data, right? And let me bring that angle as well when you're saying, yes, data, software engineers start learning data. But I've seen that data teams has been merged into, for me, software engineering is more towards front end user story conversion to satisfy a product or a customer requirement. When you create an application, you create a data model or whatever data journey based on what you need. But there are always best practices. Maybe software engineers might not know best practices. Data folks know those best practices. So you can ignore those best practices to create a data product, but you cannot ignore those if you want to live this product for a longer time or for reusability, governance purpose, audit purpose. If you simply create it, it's all going to crash because you won't have a data lineage, you won't have a security, you don't have won't have a privacy. All those things will not be there. Now tagging this with AI agent. So now we have discussed data products, we have discussed data contracts, how AI agents can play a significant role, first of all, to defining data products and defining data contracts.
Yep. So before we go there, let me just make one more comment on data contracts. So some people define data contracts the same way I would define data quality tests.
Hmm.
Yeah. Yeah, it's a bunch of tests that we apply once the data's been received on the data platform side of the
Hmm.
thing. And I'm okay with that, right? As long as we're clear that's what you're saying it is, right? That you're not talking about pushing the contract back to the owners of the data, which is that software engineering team or the product manager. Because applying tests in an automated way to the data we receive as a form of contract is a great start to adopting that contract behavior. So do it, right? And think about, okay, well, how do I make those tests a form of a policy or a contract? And then how do I expose that contract or those policies to another team and let them test their data against our contract? Right. So again, they're just small steps, but they're really valuable rather than trying to just boil the ocean, and go for this nirvana that very few people have done. So take the patterns that make sense. So let's do that with LLMs. And again, let's put some anchoring in there. When I talk about an AI agent, my definition that I've kind of got now from talking to lots of people is it is a replacement for a human for that replaces a manual task.
Hmm.
Yeah. Um, what I talk about in the Gen AI LLM space is I talk about three core patterns. I talk about Ask AI, Assisted AI, and Automated AI. So Ask AI is it's the Chat GPT experience, but let's break it down to its core pattern, right? A human asks the machine something and gets a response. And then it asks them something else and gets a response. And it goes back and forward with the machine, typically an LLM, until the human's happy to go and take the action that needs to be required. Assisted AI is where the machine is watching what you're doing and is then going to recommend based on that behavior you're doing something that you may want to do. Yeah. So it's watching what you do and it goes, actually, I've seen this lots before. I think you should do this next. Do you want to do it? Yes or no? And automated AI is where the machine just does it and you don't know about it, right? It's in the background, it's just running, and you never see it. You go, wow, that was pretty cool. How did that happen? But you're not involved, right? It's not asking you a question. And so when I do the good, the bad, the uglies, I kind of break it down in the data space between those three things, right? So let's go for the first one, right? Text to SQL, the one that everybody started off with, the one that ThoughtSpot's been working on for many, many years. Companies like Vizu have been working on it for many, many years using Knowledge Graph, right? Power BI had it for a while. Don't know if it's still there. This idea that I'm going to ask it a natural language question, it's going to write some SQL, it's going to run that SQL, and it's going to give me back the answer, potentially as text, text table or some kind of visualization, which is where everybody's going at the moment. It's kind of a great idea, but the implementations are particularly bad right now. And why are they? Because we don't have any semantic meaning against our data. It's not repeatable. It's not well structured. There is no knowledge graph we can call or ontology. We don't have a definition for customer, active customer, marketing active customer that's repeatable. The tools are non-deterministic, so I can ask the same question 5 times and get back 5 different answers. And with data, if I'm writing an essay or I'm writing a blog post, it's okay I get a different response. Sometimes that's what I want. If I want to ask how many customers I've got and I know the number's 42, I expect 42. Now, there's an interesting juxtaposition for this one. So, one out of data.world talks about this is at the moment, stakeholders trust a human, right, and a data analyst to give them the right answer. But actually, we never know it's the right answer, right? Maybe there's a problem with the Excel formula. Maybe they went and copied somebody else's SQL code that was meant for a slightly different question, just ran it and didn't know that there was a difference. But for some reason, humans believe that if I ask the machine the question of how many customers, I should get 42 every time, even though when I ask Bob versus Kate, I'll probably get a slightly different answer. So I think it's an emerging use case, but I think it's a particularly dangerous one right now because what we don't do is we don't go back to our stakeholders as part of that and say, this number's maybe not correct, right? And so if all you're looking for is some growth numbers, right, maybe it's okay that it's not correct. If you're looking for the results from a medical experiment, that's the difference between life and death, then maybe we want a human to do it right now. Yeah. So does that make sense?
Yeah, so this is one of the biggest use case nowadays in LLM world, where people want to ask LLM, as you mentioned, hey, what is the total number of customers? But you might not know that customer is which kind of customer. And a Mustafa can be a patient in a hospital, or can be a doctor itself, or can be a technician as well, and there might be 4 or 5 records over there. You might not know which kind of ID you are doing some analytics, right? So yeah, so this SQL converter, right? And I have been after this for last 15 odd years when I was doing the SQL queries, and I was saying, why the hell I'm doing SQL query? Because SQL query is also a very simple language. Select column name from a table, where date is this. This is very simple. So I was always into it. Why can't I simply ask, hey, just fetch me some data and it write down? But it's not as easy as you think, because nowadays vendors are understanding that when you ask LLM while asking, this prompt engineering is very important, and at back end metadata is very important. When you are trying to hit a table, first of all you need to know what is the metadata of table. First of all, what is table, what are column, what each column is, when one column is joining as a foreign key to another table, what is the cardinality. All those things you have to define. Indexes you have to define somewhere in the metadata, which by right we should have, which is we call it technical metadata. Last time what we used to do is whatever we can dig out, that's a metadata. Actually, that's not the metadata. We have to define the column description, and we all know every database at backend have that description column there defined, and nobody fills that up, right? So until unless you don't fill up all those things, because the biggest challenge, I won't say a challenge, but reality is, in RDBMS world we call it structured, but the context is hard coded inside the table structures in normalization form. It's hard coded. The moment you take it and put it into LLM, which is again a text, LLM will not know the first column is employee ID, second column is, address. This address is for employee ID, or maybe there's another column is a location. This address is a location of an hospital. You do not know until unless you define it. So when you convert this structure into text, right, or metadata into a text, you have to define the what do you call it, graph theory, how everything connects with it. If you can't do it, I don't see this problem solving. As you correctly mentioned, hey, how many customer? It says 42. And even if you know the 42 correct answer, you ask LLM, hey, I think there was another customer you might have missed. What LLM will say? Yeah, my apologies. It says, I'm sorry, I missed this point. Yes, there is 43. So,
Yeah, and look, there's some reinforcement patterns that people are trying, right? So the idea that we enhance our metadata, our
yeah,
business ontology, with extra text that hints, right?
yeah,
We alias columns for common used words, right?
yeah.
So if it's called ID, we alias it with customer ID, so we give a
Hmm.
hint. They're all good things, and actually, ideally, it's going to force us to start capturing some of this business metadata, this business
Oh, yes,
context
yes,
that
yes.
nobody ever did before, right? There's some other ones I've seen. So when we do it, because we're still experimenting with it, we will pass back sample data to
Mhm.
the LLM, right? And that helps reinforce it. We've tried some patterns where we will give it the question, get the SQL, run the SQL, give it back the data and say, what do you think the question was? We'll fire the question off 3 times, get the SQL 3 times, run it and compare the data to see if it's the answer. We'll do a bunch of loops around that. The thing about that then is it becomes expensive and
Hmm.
takes a long time. So one of the benefits of text to SQL is it's meant to be fast, right? Ask a question, get an answer. When you're going back and forward with the LLM, if you're a normal company, not people that can afford the millions, you're not getting a response time in sub-second, right? Because it's going doing
Yeah.
a whole lot of heavy lifting. There's 2 patterns though that I see as valuable that we can implement today. So the first one is Copilot, right? That idea of assisting an analyst. So either the Ask AI, where the analyst is saying, hey, I need some SQL to do this, and it's coming back and helping them start that SQL conversation, right? It's not the answer, but it makes them faster to do that work. Or the Copilot's watching what they're doing and saying, actually, we think you've got that query wrong. You may want to do this. Yeah, so for performance reasons, you may want to petition it on the date column because it's BigQuery, and if you don't run the petition, it's going to take twice as long. Or actually, your context is slightly out. That looks like it should be a left join, not an outer join for these reasons, right?
Mhm.
Those are valuable patterns. The second valuable pattern is that we use the natural language for where it has power. So if you think about it as a stakeholder, one of the problems is I've always had to be very specific about the language I use to find the dashboard or report that answered my question.
Mhm.
But what that then gives us is the ability to remove that barrier. So if we have humans or analysts that are basically curating the answers, right? So how many
Mhm.
customers do we have? Well, that's a common question. I can write a query that I know will give me the right number of customers every time it's run because I've done that governance, right? I've done that stewardship, and I've done that work. And then what I can do is expose those questions that these curated pieces of data answer to the LLM. So as a stakeholder, I can go in and say, how many blah, blah, blahs are there? And it can come back and say, based on what you asked me, here's 3 questions that have curated answers. Which question do you want to use? And when you click on that, it then runs the curated query or dashboard, right? For me, that is a great stepping stone to using LLM to allow us to ask natural language questions of our data. Yeah. And be accurate, depending on the
Yes.
analyst. Yeah.
Yeah. See, as you mentioned, analysts, right? I'm a big fan of this LLM chat things to be used by analysts, not by top management. I feel these can really make a big difference. If you have a good developer, you already know how to create queries, then yes, you use LLM, it will reduce your 10 hours job into 1 hour. No doubt about it for me. Because you know whatever it's saying wrong, you can ask him to fix it. Ask
Yeah.
it fix it and it fix it. But the moment you out based on the your analysis, you want to create a dashboard because end of the day, for a decision making, critical decision making, KPIs remain same. If not the same, top management already know what they want to ask. A high level decision cannot be taken that you are in a meeting of a 10 people and you just thought a new angle and you simply take a decision. Normally top management don't do that. If the new angle comes, they go back to their team, they make sure whatever they're thinking is fine, data support that, and then they make it as a KPI. So for me, analysts can use this heavily. It will dramatically, it'll change the development time. But the moment you have an output, solid output, you give it still to your IT team to develop that KPI in a dashboard. That's a takeaway for me, not giving to business. Because the moment you give this business and business shows distrust of the data, your whole solution gone actually. Whole investment
But
is
the
gone.
good but the good news is we can blame the LLM, not us now, right? Because we now I will preface this, right? If you had asked me 5 years ago when I thought a machine would turn up that I could talk to and chat with and have a conversation and feel like I was talking to a human, I would have said about the same time I get flying cars. Yeah. and then ChatGPT turned up. So there is a chance that we get what I call the magic sorting hat. I'm a great fan of Harry Potter. So for all the people
Yeah.
that haven't seen Harry Potter, when you're a young wizard, you go to Hogwarts and basically you get sorted, right? The hat tells you which group you're part of. And so for me, there is a chance that somebody's going to innovate and come up with the magic sorting hat where we can just throw dirty data in it and the magic sorting hat sorts it out. And we can ask it any question that will give us an accurate answer, right? There is a chance. I'm probably going to say I'll see that about the same time as I see flying cars.
Yeah.
But if somebody solves that, then the whole data domain's changed, right? But before then, let's go back to another use case. So let's go do a good one, right? And then I'll go back into the real ugly. So we use the LLMs for data quality rules. So in our product, we have all the standard expectations, right? The is null, is not null, is a date, is not a date, is an email, all those ones that are regex and relatively standard and you kind of understand them. But then the problem is, I kind of talk about it as for me, I can't code, won't code, don't code, right? And so whenever I go and try to do a custom quality rule, I got stuck in regex hill. Yeah.
Hmm.
So how did I do? I fix that. Well, I do what most people did, right? As I look at the data, and because I was using ChatGPT and I don't trust it from a privacy point of view, I then go to ChatGPT and give it dummy data that kind of looked the same but wasn't the customer's data. And I'd say, give me the regex, and it'll give me a regex to do what I want. And then I'd go into a website, right? And I'd type in that, cut and paste that regex in and say, validate the regex for me to make sure it was actually going to run. And then I'd go back and in my code, I'd put in that regex as a quality rule. So that's quite an onerous set of steps, right? So what we do now is when you want to create a quality rule, and we call them trust rules, you effectively pick the column and the LLM comes back and it does three things. It says, looking at the data, this is what I think the data is. So it gives me a reinforcement that it's seeing the same data I'm seeing, right? And we kind of agree. It's that data. It then says, here's the regex you should run. Yeah, or the rule, the code. It says, here's an explanation of what that code's doing. So it's telling me a story about that code because I can't read the code. And then we apply that rule to a subset of the data and see whether it passes or fails. So we get this visual clue back about pass, fail. And then I can tell it to change the prompt. And for me, that has changed the amount of time and frustration and cognition I need to create data quality rules.
Yeah.
And so for me, that's that idea of assistance, right? It's looking at the data, it's making some recommendations. I can accept them or deny them. I can ask it to change something. And that's really valuable because that saves me a whole lot of time and a whole lot of thinking and a whole lot of stress because I hate regex. So there's a great example, right? Is think about how you can use the LLMs to automate some of the work that you do. That's what we call drossy, right? It's just horrible, chunky work you got to do day in there out. Get the machine to do that stuff. It's really good at it.
I absolutely agree, right? Last time we want to find something, we used to go and dig out the white papers from X, Y, Z location. Now you ask ChatGPT, hey, can you tell me which companies have done this, did what? They will go and find, it will go and find out all those things. So yeah, for me, yes, this is the right use of LLM to, again, it can be your assistant, right? It can support you to dig out something, but trust is something, yeah, still humans are still there. And by the way, I'm becoming a big fan of creating your own AI agent. On my laptop itself right now, I'm developing using this B agent framework which IBM has come up. I'm just exploring that. It'll help you create your own agents on your laptop. So I'm thinking the same thing, that there should be an agent sitting just like my Siri on my iPhone, right? You ask that, and it is your own data. It's not going online. So yeah, if we end up creating a small AI agent for your own self, yeah, it'll be super good. I'm all for it actually.
Think about the ugly one, right?
Yeah, yeah.
Because this is the one that everybody's doing.
Hmm.
So what people are doing is they're saying, I've got a bunch of data.
Mm-hmm.
Let's get the LLM to create the context, the business context, the metadata about that data, not technical data, but business metadata. Let's use
That's a
the
good point.
LLM to
Yeah.
create text that describes that data. right? And that kind of makes sense. It's not bad at doing it. But let's think about that. Then the next thing we do is we get the LLM to use that context to write text to SQL. We use it to reinforce the quality rules. We use it as an input. So now what we've got is the machine making shit up to
Yeah,
then use to make other stuff up.
yeah, yes,
And
yes.
that is incredibly dangerous, in my view, right? Because we don't know where the errors come in. We're never going to see them. The thing I have with it though is nobody ever fills out the context. It's an onerous task. So would you do it as a draft, right? And we've built that in our products where it comes back with a suggestion. But then what we see is you just go, oh yeah, that's good. Yes, 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 right? You just accept it because you want those drafts to be production and you don't really review it. And so I don't think it's a solved problem yet. I think it's great at creating that context, making that job slightly faster, but I haven't found a pattern that actually makes it useful and accurate. Yeah, without humans just doing bad things to it. So for me right now, the machine's creating the business context about our data that is then used in other processes is incredibly dangerous. It's an ugly pattern today.
You are
Um,
absolutely right. See, when we ask LLM to create business metadata from the data, that data is mostly unstructured data, either text, mostly text, right? And we all know that what is the reason we call it unstructured, because unstructured data quality is a problem. Not a problem, is the reality. Bad data quality is the reality of unstructured world, because hallucinations are there. You can say something, it means something else, right? And based on that data, what you're asking LLM to create the business metadata, and business metadata has to be 100% accurate so you can create products on top of it. So I am absolutely with you. You cannot go, you have to go the other way around. Business meta has to be defined by business owners. And I think that is where this graph theory comes into picture. In graph theory, in knowledge graph, you actually defines how each entity, each category, each concept, each node has a relationship to another relationship. All those things comes, and what attributes, structure, weight of each node and relationship is there. Once you define that, then yes, then you throw that into LLM and ask LLM, hey, this is your text, this is the graph theory, now make sense of it, then it'll make sense. I haven't seen that use case, but I personally feel that is how it need to be done. But again, this is something very opex cost, is not a capex cost. Once it's an opex cost, totally majorly management do not agree to spend money on it. Right, that's a dilemma as
Um,
of now.
and, and again, we're going to come back to fast and ugly
Fast.
and slow and accurate, right?
Accurate.
And there are going to be organizations that believe and that actually the risk of having the LLM do all the work quickly is less than the value of having that time to market, right? And there'll be other organizations that go. So I had someone on the podcast, it'll come out next year, talking about using LLMs to basically take EU regulations for a bank
Hmm.
and apply them to mortgages and then flag the mortgages as valid or breaking regulations.
Hmm.
And then they talked about they've started off with it as an assisted model, right? So it's basically highlighting to the bank person, this one looks like a mortgage that's broken the covenants. You need to go and check it. But over time, they'll move it to automated when it's accurate. And so I said to them, oh, because they were an ex data miner, right? They've been around for a while, so they've done back in the days, before data scientists, back when we
Yeah,
called it
yeah,
data
yeah.
mining. And I said, back then, 80% of the time was doing data work, right? And then you might, you do some quality stuff and then some feature flagging, and then eventually write a model. Um, and he said, oh, look, two things are different now. We don't have to prepare the data as much because just dumping data into the LLMs actually is a good use case. But he spends 50% of his time writing unit tests for the model in dev and 75% of his time tuning those unit tests in production. And so when we're talking about enterprise, that's what's going to happen, right? We're going to spend a whole lot more time doing validation than we are doing development. So intriguing.
Yeah. So yeah, I always quote this example which I got from Department of Correction from New Zealand actually. So whenever we went over there, we started evaluating their code and we realized their code is super good. So I asked one of the guy over there, how come your code, 90% of your code is super good? So they told me that their trend is out of 20, one or two people are just there on an OPEX cost who keep optimizing the cost. Their job is not for a new project. Their job is just to go and check how to optimize the existing code. So that is the OPEX cost. I think that trend have to come into data world now, especially in AI agents, that there has to be a team who should keep validating what's being implemented and how it can be improved, because we all know after every 3 months to 6 months, a new, better and cheaper technology is coming. You cannot stick with the one technology more than a year. Keep Things keep changing. So your product has to be flexible enough to adopt all those things. So I think it's great to bounce ideas with you. And actually, I learned a lot. Thank you. Have a nice day.
Excellent.
Pleasure catching up. Take care.
It's been great. Thank you.
Thank you. Bye bye.